In this video, we're going to do a quick review of the calculations and concepts that we saw on the introductory mole lesson. So the first concept is going over, well, what the mole actually is. And so if you remember, we said that the mole is defined as 6.022 times 10 to the power of 23 particles. And particles could mean atoms, it could mean molecules. So it could mean atoms of, let's say, copper, or it could mean molecules of water. It's whatever you're really dealing with. So if I say I have a mole of something, what it means is that I have 6.022 times 10 to the power of 23 of that something. If I have a mole of pennies, I have 6.022 times 10 to the power of 23 pennies. If I have a mole of elephants, I have this many elephants. And so chemists will use this number when they're counting atoms because atoms are so small. You can have moles of atoms in a glass of water. So many molecules of water in a glass of water. And the reason that you can fit all those molecules in the glass is because molecules and atoms are so small. But I'm sure you could realize that if you had a mole of, let's say, elephants or peas or pennies, that would take up much more space just because pennies and peas and elephants are much larger. So for more on that, you can watch the videos that were posted online regarding the mole concept and how much space different moles of different items would take up. So right now, the important thing that you need to understand is that 1 mole is this much as a quantity, and this is given the name Avogadro's number. So this number here is called Avogadro's number, after the scientist who came up with this idea that in a mole, MOL for short, there's 6.022 times 10 to the power of 23 molecules. So we often represent that by the symbol uppercase N and then uppercase A but subscript. So that's Avogadro's number. And you can write down the units for Avogadro's number as 6.022 times 10 to the power of 23 particles per mole. So now we're going to take a look at another concept called the molar mass. The molar mass is basically the mass of 1 mole of a particular substance. So if I had a mole of, let's say, H, it would have a mass of 1.01 grams. And I would put that as grams per mole. You can figure out the molar mass of an element by looking at the periodic table. If you go to the periodic table, you'll notice the atomic mass. The atomic mass tells you how much one atom of that element weighs. And I'm simplifying a little bit, but that's generally what it tells you. So if you had 1 atom of H, it would have an atomic mass of 1.008 AMU, which is atomic mass units. If you had, let's say, 1 carbon atom, it would have an atomic mass of 12.011 atomic mass units. Now, when you're doing chemistry, you're not really dealing with 1 atom at a time. In reality, you're dealing with moles of atoms and moles of molecules. So what scientists have determined is that these masses can also apply to moles of the atoms. So if you have a mole of carbon atoms, that mole is going to weigh 12.011 grams. And we'll put grams per mole because that's the unit for the molar mass. The molar mass symbol is often written as uppercase M, but there's many other variables that use that symbol as well. So we'll often use it in our notes, write it in notes as MM. Sometimes you might see it written as molar mass for whatever you're calculating. So for example, if I want to find the molar mass of Cu, of copper, I'd write MCU or MMCU. So to find the molar mass of elements, you simply have to look in your periodic table. If I were to ask you for the molar mass of lithium, you'd say it's 6.94 grams per mole. So if you had 1 mole of lithium, it would weigh 6.94 grams. So notice that different elements have different molar masses. If you had a mole of nitrogen, it would weigh 14.007 grams. A mole of oxygen would weigh 15.9999 grams. We could round to 2 decimal places. Make sure you keep 2 or 3 decimal places when you're doing your calculations, just so that you don't round too much, because answers will vary quite a bit since we're dealing with very large and small numbers. So you might also be asked to find the molar mass of compounds. To do that, you simply have to add the molar masses of all the elements from which that compound is made. So let's go to the examples in the box that you have in your notes. Find the molar mass of boron trifluoride. So first you have to write out the formula. Boron is B and trifluoride BF3. Then what you do is you go look in your periodic table and you find the molar mass of each of those. So boron has a molar mass of 10.81 grams, as you can see over here. So we have 10.81 grams, and we're going to write molar mass of BF3, 10.81 grams per mole, because the molar mass is per mole of the substance, plus 3 times the molar mass of fluorine, because there's 3 fluorines in here. So 3 times the molar mass of fluorine, which is 18.99, grams per mole. So in your calculator, you'd be doing 3 times 18.99 plus 10.81, and you'd get 67.78 grams per mole. So if you had 1 mole of BF3, it would weigh 67.78 grams per mole. And again, the reason that 1 mole of helium doesn't weigh the same as 1 mole of boron is because helium as an atom just weighs a different amount than boron as an atom. Helium has 4 protons, 2 protons, 2 neutrons, so it has a mass of 4. Boron, on the other hand, has a mass of 10. It's kind of like saying a mole of elephants and a mole of feathers. Yes, they're the same amount. You have 6.022 times 10 to the power of 23 feathers and 6.022 times 10 to the power of 23 elephants, but each elephant weighs more by itself. So, of course, a mole of elephants will weigh more than a mole of feathers. The other example you had in your notes was phosphorus pentachloride. So again, you start off by writing down the formula for the compound, and then you add all the molar masses that are involved in your compound. So we have phosphorus, which is 30.97. Don't forget to write your units in. You need to put those units in. Grams per mole plus, and let's write molar mass of PCl5, plus 5 times the molar mass of chlorine, which is 35.45 grams per mole, put that into your calculator. 30.97 plus 5 times 35.45, and you get 208.22 grams per mole. So in this video, we saw the definition of the mole, which is also called Avogadro's number, which we saw to be equal to 6.022 times 10 to the power of 23 particles, which could mean atoms or molecules. And we also saw something called the molar mass, which is basically just the mass of 1 mole of a substance. You should be able to try to find the molar mass of water, and we can attempt other problems in the next video.